Okay, second part of chapter 3 of chemistry. We're starting on page 81 in your book if you want to follow along. We're going to be talking about the energy of light. You have your note sheet that you can finish filling in. Energy is measured in a unit called a joule. It's found by James Prescott Joule. We abbreviate it with a J. It gives the example in here of a small apple. If you take a small apple, lift it a meter high from where you grabbed it, that takes 1 joule of energy. So not a whole lot of energy. But we also know that there's energy in light, and we can find the amount of energy in light based on the frequency of the light. Remember, we can find frequency if we know the wavelength. And they're proportional just by using constants. Which, remember that C is a constant. We always know what it is. So, this equation, which is, hopefully you can see, energy equals H times F. H is a constant. It never changes. Okay? And it's on your paper. It's 6.63 times 10 to the negative 34th joule times second. Joule seconds. Okay? So, if you want to rearrange this equation to get the other versions, to find out what other things are, H would equal E over F, but you're never going to have to find H because it's a constant, you know it. So, F would equal E over H. You just take that over there. E divided by H would give you the frequency. So you can put these, I'll bring a note card next week and we'll add our equations and constants to a note card. These are just, and the constant, which is in your notes there. Okay, energy and frequency are directly related. You can see that. If the frequency goes up, the energy is going to go up. If the frequency goes down, the energy is going to go down. Let's look at example 3.4. That's on page 82 in your book if you want to follow along. It's maybe a little easier to see it in there than on my board. Let's see if I can increase the light a little bit. Okay. The shortest wavelength of visible light is 380 nanometers. So we have a wavelength of 380 nanometers. What is the energy of that light? Okay. So first we have, this is in nanometers, and we need to make it in meters because joules and the constants and everything are in meters. So we need to go to meters. So nano is times 10 to the negative 9th. That's what nano means. So times 10 to the negative 9th is going to give us 3.80 times 10 to the negative 7th, because this will go forward 2 spots, so that's positive. And that would be meters. Okay? Now, we need to find the energy, we have to first find the frequency. Wavelength doesn't get us anywhere. But we can find frequency is C over lambda. C is 3.00 times 10 to the 8th divided by 3.80 times 10 to the negative 7th. This is a great time to make sure you can put these into your calculator correctly. If you can't, we can try this when we see each other. 7.9 times 10 to the 14th, 1 over second, or hertz. Okay, so that is our frequency. Now that we know our frequency, we can put it in our energy equation. It's just a 2-step problem here. Energy is H times F. So energy equals that H constant, which is 6.63 times 10 to the negative 34th times our frequency, 7.9 times 10 to the 14th. Again, another time to just make sure your calculator's working right. When you put that in, you should get 5.2 times 10 to the negative 19th. And that would be in joules. We measure energy in joules. Okay? So make sure that as you're doing this problem that you can put those numbers in your calculators. if we have wavelength, we can find frequency. Once we have frequency, we can find energy. Okay? Just don't complicate it any more than just plugging in the numbers. Okay. So, photons are tiny packets light waves come in. Photons are tiny packets that light waves come in. So light waves come in little packets called photons. Okay, I put on the back of this sheet some Bohr model pictures. We talked about that a little bit on the first day, how if it's less than 20, we can make a simple Bohr model. If your project has more than 20, I want you to Google a Bohr model. I don't want you to just paste a picture. I want you to draw it. Now, Elizabeth asked me if she had to do the individual protons and neutrons. No, you can write that there's 57 protons and 58 neutrons. Just write the numbers in the middle. But I want all the electrons on your model shown. Your book has a good picture on page 85. And I have a little bit of a picture here. Electrons absorb extra energy. So when it absorbs energy, it's going to move to the next ring out. But it doesn't like being there because it's not very stable. Stable where it's supposed to be. But when it absorbs extra energy, it moves out. But it needs to come back. When it comes back, it releases energy. And that releasing the energy is what emits the light. The electron moving from one level back to its stable place releases the light. This little picture shows it pretty well, the one that you have here. As it moves up a ring, it absorbs energy, takes energy from it. When it goes back to its stable place, it's going to emit energy, which will come out as light. Okay? Bohr models explain a lot, and they help give us a picture. They are not completely accurate. And we'll talk a little bit more about where they go. I think it's the next chapter we talk a little bit more about some of that. Then we get into a little bit more fun chemistry stuff. Spectroscopy, some of you looked through the little lights. We all did the flame test this week. Spectroscopy is identify chemicals by studying the light they emit. So we can tell what chemicals are in something based on the color of light that they emit. And actually, they have machines where they can actually get a really good readout. Your book on page 84 shows some pictures of the different readouts they can get based on a chemical. So they can put a chemical in and find out exactly what wavelengths it's emitting. But that's what spectroscopy does, is you can see the wavelengths that are being emitted. Okay? Oh, actually on page 89 it gives some also. Okay. That is all that's left in the chapter for this part. So then you can work on your work. If you have any questions about any answers for the review, feel free to shoot me a text or message, and I will tell you what the answer is if you're working on any and you're unsure of what the answer should be. Thanks, bye.